You won't believe how close we came to losing World War II in Europe. Not on the beaches, not in the trenches, but high above, in the very skies over Germany. Imagine for a moment. The year is 1943. You're a young American pilot, strapped into the cockpit of a B-17 Flying Fortress. Your bomber lumbering through a sky filled with anti-aircraft fire. Flak bursting all around you like malevolent fireworks. Your target, deep within Nazi Germany, Berlin. Munich, the industrial heartland of the Third Reich. Your mission is vital, but your chances of survival. Grim, brutally grim. Day after day, week after week, Allied bomber crews were sent on these suicide missions. They were called deep penetration raids, and the name itself was a chilling prophecy. Our bombers would fly hundreds of miles into enemy territory, often unescorted, exposed, and vulnerable. Why unescorted? Because the fighter planes of the time, the mighty P-47 Thunderbolts, the agile British Spitfires, even the innovative P-38 Lightnings, simply didn't have the fuel capacity, the legs, to go the distance. They'd protect the bombers for a while, then have to turn back, leaving their comrades exposed, floating targets for the waiting wolves of the Luftwaffe. This wasn't just a tactical problem. It was a crisis of monumental proportions. The 8th Air Force, the spearhead of the strategic bombing campaign, was bleeding out. Losses weren't just high, they were unsustainable. We're talking 20, 25, even 30% of an entire formation wiped out in a single mission. Think about that. 1 in 4 planes, 1 in 4 crews, gone, every time they flew. The infamous raid on the ball-bearing factories at Schweinfurt in August 1943, for example, saw 60 out of 376 bombers shot down, and another 100 heavily damaged. These weren't acceptable losses. They were a death spiral. Morale was plummeting. Experienced air crew were disappearing faster than training programs could replace them, and the entire daylight bombing strategy, designed to cripple Germany's war machine and avoid a costly ground invasion, was on the brink of collapse. The Germans knew it too. They saw the Allied fighters turn back, watched the slow, heavy bombers come closer, and then descended upon them with a terrifying impunity. Their Focke-Wulf 190s and Messerschmitt 109s, deadly in the hands of experienced pilots, tore through our formations. They were literally writing the book on how to dismantle a bomber stream. The skies over Germany were becoming a graveyard, and it felt like there was no answer. But then something shifted. A whisper became a roar. A new shape appeared, high above the bomber formations, a sleek silver guardian with an unmistakable silhouette. The P-51 Mustang. And with its arrival, the rules of aerial warfare were fundamentally rewritten. Germany, in the autumn of 1943, looked at their radar screens, saw these distant fighters, and realized with a cold, hard dread they couldn't win the skies anymore. The story of the P-51 isn't just a tale of superior engineering. It's a saga of desperation, audacious innovation, international collaboration, and a profound shift in strategic thinking. It's the story of how an airplane, initially dismissed as a failure, became the instrument that shattered the Luftwaffe's back and opened the door to Allied victory. What's truly fascinating, and often overlooked, is that the P-51 almost never happened, and when it did, it wasn't even built for the Americans first. Its origin story begins not with a grand vision, but with a frantic phone call from the British in April 1940. With the Battle of Britain looming, they needed more fighter planes, any fighter planes, and they needed them yesterday. They approached North American Aviation, a company known for trainers and bombers, not high-performance fighters. The request was outlandish. Don't just build someone else's fighter under license. Design and build an entirely new one, from scratch, in a ludicrous 120 days. Most companies would have laughed them out of the room. This was an impossible timeline for an impossible request, especially for a company without fighter experience. But North American's president, James Dutch Kindleberger, saw not just risk, but immense opportunity. He assembled a team led by chief designer Edgar Schmude, a German-American engineer who brought a unique, almost contrarian perspective to aircraft design. Schmude and his team faced a monumental challenge: how to create a fighter that could outperform existing designs, yet be built quickly and efficiently, bypassing the complex, labor-intensive methods common at the time. Their solution was deceptively simple, yet revolutionary. Instead of intricate multi-panel construction, they designed the Mustang with large single-piece panels. This meant faster manufacturing, tighter tolerances, and critically, an exceptionally smooth outer skin. Think about it. Every rivet, every seam creates drag. The Mustang minimized these imperfections, gliding through the air with an aerodynamic purity that was unprecedented. They also made brilliant choices about the aircraft's fundamental physics, its weight distribution, its wing profile, even how they positioned the radiator. In a stroke of genius, the radiator, often a source of drag, was designed to actually produce a small amount of thrust through careful ducting, essentially turning a liability into a subtle advantage. This wasn't just good design, it was elegant problem-solving. The prototype, the NA-73X, took to the skies on October 26, 1940, a mere 102 days after the contract was signed. It was a staggering achievement. Test pilot Vance Breese immediately praised its speed and stability. The airframe itself was a marvel, but it had a fatal flaw, an Achilles heel that almost relegated it to the scrap heap of history: its engine. The early Mustangs were powered by the American Allison V1710. While reliable, this engine simply didn't perform well above 15,000 feet. It was great for low-altitude ground attack, but in the stratosphere, where the crucial air war over Europe was unfolding, it choked. Many aviation experts, understandably, dismissed the Mustang as just another capable, but not exceptional, fighter. Good, but not great. Not the savior everyone was desperately praying for. And here's where the story takes a turn that exemplifies the power of collaboration and unexpected insight. In April 1942, a Rolls-Royce test pilot named Ronald Harker flew an Allison-powered Mustang. He felt its incredible airframe, its inherent grace, and immediately recognized its untapped potential. He knew, with an engineer's intuition, what was missing: the supercharged Merlin engine, the very engine that powered the legendary Spitfire and Hurricane. The Merlin, with its two-stage supercharger, could maintain power at high altitudes, precisely what the Mustang desperately needed. This wasn't just a simple engine swap. It was an act of wartime alchemy. It required extensive redesign of the Mustang's cooling systems, careful rebalancing of weight, and structural reinforcement. But the results were nothing short of miraculous. The marriage of American manufacturing prowess with British engineering insight and combat experience created something neither nation could have achieved alone. It transformed a mediocre aircraft into an aerial predator of unparalleled capability. The Merlin-powered Mustang, specifically the P-51B, and later the iconic P-51D, embodied three revolutionary concepts that fundamentally challenged traditional fighter design. First, range without compromise. Before the Mustang, it was an accepted truth that extended range meant sacrificing performance. More fuel equaled more weight, which meant less maneuverability, slower climb rates, and reduced speed. The Mustang shattered this assumption. Its laminar flow wing, the result of years of advanced aerodynamic research, maintained smooth airflow much further back than conventional wings, dramatically reducing drag. This, combined with its incredibly clean fuselage design, gave it a phenomenal efficiency advantage. Wind tunnel tests showed it had 30% less drag than comparable fighters, directly translating into superior range and speed. It could fly far, and it could fly fast. Second, integration of long-range capability with air superiority performance. This was the holy grail. The P-51D, with internal fuel tanks holding 489 gallons, more than double a Spitfire's capacity, and external drop tanks, could fly over 1,650 miles. It could escort bombers all the way to any target in Germany and back. But critically, when it engaged, it wasn't sluggish. It could outfight the best German interceptors, achieving a staggering kill ratio of roughly 11.1 against Luftwaffe aircraft. It wasn't just a guard dog. It was a wolf, capable of outrunning and outfighting anything Germany could throw at it. Third, manufacturability without quality compromise. North American aviation perfected production techniques, pioneering assembly line methods, specifically for aircraft, that allowed them to build Mustangs faster and with better quality control than traditional methods. They cranked out over 15,000 Mustangs during the war, maintaining incredibly high standards. This industrial might, the ability to rapidly produce sophisticated machines, was as crucial as any design innovation. America's factories became a weapon in themselves. The operational deployment of the P-51B in December 1943 marked the true turning point. Suddenly, American bombers were penetrating deep into German airspace, not alone but with a tenacious silver escort. The psychological impact on German fighter pilots was immediate and devastating. They had grown accustomed to easy pickings, to diving on unescorted bomber formations with relative impunity. Now, hundreds of miles from Allied airfields, they were confronted by aggressive, high-performance fighters that could match them in speed and maneuverability. And then some. Imagine you're a German fighter pilot, a veteran of countless engagements. You spot the bombers, your usual quarry, but this time, you also see those sleek new escorts, the little friends, as the American bomber crews called them. You dive, ready for the kill, but instead of scattering, they turn into you. They climb faster, dive harder, and their 650 caliber machine guns spit fire with frightening accuracy. The tables have turned. You are no longer the hunter. You are the hunted. This shift was more than just tactical. It was a profound blow to the Luftwaffe's morale and its strategic capabilities. They were forced into a defensive posture, reactive rather than proactive, playing to American strengths in numbers, training, and aggressive tactics. For the American bomber crews, the sight of a P-51 was akin to seeing an angel. Picture Sergeant Frank Johnson, a B-17 waist gunner. Before the Mustangs, every deep mission felt like a coin flip with death. He'd seen friends vaporized, planes spiraling down in flames, the sky littered with parachutes. The fear was a constant, icy knot in his stomach. Then came the Mustangs. He recalls the first time he saw them deep over Germany, circling protectively. He'd hear the chatter on the intercom. "Little friends are here." And suddenly, that knot would loosen. Hope. Real, tangible hope. The odds of coming home, once negligible, felt real again. Losses plummeted from above 20% to under 5%. That's not just a statistic. It's thousands of lives saved, thousands of airmen who flew another mission, thousands who made it home to tell their stories. But the P-51's contribution went far beyond simple escort duty. Mustang pilots were encouraged to pursue German fighters aggressively, turning the entire nature of air warfare offensive. They didn't just defend, they hunted. Both in the air and on the ground, P-51s strafed airfields, destroying German planes before they could even get airborne, denying them rest and refit. This constant pressure meant German pilots were always on edge, always fighting, always losing. The pinnacle of Mustang development, the P-51D, arrived in mid-1944. With its iconic bubble canopy offering 360-degree visibility, 6 powerful 50-caliber machine guns, and refined aerodynamics, it was arguably the finest piston-engine fighter ever built. Pilots lauded its handling, calling it forgiving for novices, yet capable of extraordinary performance in expert hands. It was the right machine, at precisely the right moment, allowing the Allies to accelerate the war's conclusion. The P-51 fundamentally enabled a strategic shift. Instead of just trying to survive to the target, Allied air forces could now actively seek out and destroy German air power wherever it was found. This offensive capability was critical to operations like Big Week in February 1944, where concentrated attacks on German aircraft production facilities, protected by Mustang escorts, dealt crippling blows to the Luftwaffe's ability to replace its catastrophic losses. Ultimately, the air superiority established by aircraft like the P-51 was as crucial to Allied victory as D-Day itself. Without command of the skies, the Normandy invasion would have been far more costly, if not impossible. Imagine Allied troops landing on the beaches, only to be hammered relentlessly by German ground attack aircraft and bombers. The Mustang cleared the skies, creating the conditions that made ground operations feasible. It wasn't just a machine of war. It was an instrument of liberation, carrying the hopes of free people within its aluminum frame. Now, while the Mustang's success story is undeniable, it's important to acknowledge its complexities and the human cost involved. Critics point out that its dominance came at a horrifying price for thousands of German pilots. By 1944, the Luftwaffe, desperate, was sending young men into combat with minimal training, sometimes just a few hours in a fighter. These became aerial massacres, strategically necessary perhaps, but undeniably tragic. It raises troubling moral questions about the nature of technological warfare and the dehumanizing aspects of total war. The Mustang's role in enabling the strategic bombing campaign also connects it to one of World War II's most controversial aspects. While escort fighters made precision bombing theoretically possible, the grim reality was often area bombing, which caused massive civilian casualties in cities like Dresden and Hamburg. The line between military and civilian targets became tragically blurred, and some historians argue that the P-51's effectiveness, in a sense, prolonged certain aspects of these devastating campaigns beyond strict strategic necessity. Furthermore, it's vital to see the Mustang within a broader technological context, not as the only hero. Aviation historians sometimes argue that its towering reputation overshadows other equally important aircraft. The P-47 Thunderbolt, for example, while shorter ranged, was arguably more versatile and incredibly survivable, especially in ground attack roles. Its massive radial engine could absorb tremendous battle damage and still bring pilots home. And the P-38 Lightning, despite its struggles in the European winter, excelled in the Pacific, offering twin-engine reliability over vast ocean expanses that the single-engine Mustang couldn't match. No single aircraft is perfect, and the P-51 was a solution for a specific problem at a specific time. And let's consider the timing. Germany was already developing advanced jet aircraft like the Me-262 Schwalbe, which could easily outperform any piston-engine fighter, including the Mustang. Had the war dragged on into 1946, the Mustang's dominance would likely have been short-lived, raising fascinating what-if questions about the permanence of technological superiority. The Mustang's story, then, is also a testament to the advantages of American industrial capacity. While German engineers were often incredibly innovative, producing advanced designs, American manufacturers could produce reliable aircraft in quantities that simply overwhelmed Axis production capabilities. The Mustang's success was as much about America's ability to mass produce as it was about superior design philosophy. So what profound lessons can we draw from the story of the P-51 Mustang, beyond the heroism and the roar of its Merlin engine? First, it's a powerful reminder that practical superiority often matters more than theoretical perfection. The Mustang wasn't the most advanced or exotic fighter of its era. It was the right aircraft, at the right time, designed with clear priorities, range, speed, and fighting capability, and then manufactured with unprecedented efficiency. In conflict, the ability to effectively implement and deploy a robust solution often outweighs the pursuit of an ultimately unachievable, perfect design. Second, it underscores the critical importance of international cooperation. The Mustang as we know it, the war-winning machine, would not have existed without the marriage of American manufacturing prowess with British engineering insight and combat experience. Neither nation could have created it alone. In today's increasingly complex world, facing global challenges from cyber warfare to climate change, this lesson about collaborative technological solutions remains profoundly relevant. Third, the Mustang symbolizes the power of adaptability and iterative innovation. It started as a promising airframe with a debilitating flaw, was nearly discarded. But then, through a willingness to experiment and integrate new components, the Merlin engine, it transformed into a legend. It's a testament to not giving up on a good idea just because the first iteration isn't perfect. True innovation often comes from refining and adapting existing technologies. Fourth, it highlights the enduring strength of democratic innovation versus authoritarian regimes. The Mustang demonstrated that when free societies are properly motivated and organized, they can outproduce and out-innovate totalitarian systems, despite the latter's early advantages in central planning or initial breakthroughs. It was a tangible manifestation of American industrial democracy's ability to marshal resources and creativity that its adversaries simply couldn't match. Finally, and perhaps most importantly, the P-51 Mustang's legacy extends to how we approach complex challenges today. It teaches us that decisive advantage often comes not from a single revolutionary breakthrough, but from the intelligent combination of existing technologies applied with a clear strategic vision and supported by a robust industrial capacity. Whether we're talking about national defense, economic competition, or tackling global crises, the principles that made the Mustang successful, the integration of diverse technologies, a focus on practical performance over theoretical ideals, and the ability to mass-produce sophisticated systems, remain incredibly relevant. The P-51 Mustang didn't just win battles. It won the war in the air over Europe. It helped establish American technological leadership that continues to this day, and in doing so, it helped preserve the democratic values and freedoms that define the modern world. In an age when those values face new challenges from various authoritarian regimes and global uncertainties, the story of the P-51 Mustang reminds us that focused innovation, adequately supported, can still change the world and defend the cause of freedom. Those silver fighters, streaking across German skies in 1944 and 1945, were more than just machines of war. They were symbols of hope, instruments of liberation, carrying within their sleek frames the determination of free people everywhere. Their legacy is a standard worth remembering, and a testament to what can be achieved when ingenuity, courage, and collaboration unite against overwhelming odds.